Please enjoy hundreds of my video lectures on telecom and wireless. Please do not forget to subscribe to my channel. Please also like my videos. Please share my channel with your friends and colleagues. Thank you.
Okay, let's look at authentication and encryption mechanism that is available in CDMA 2000. It will be more like a tree. Please look at the diagram that's appearing on your screen. The authentication and encryption tree that is used in CDMA is captured in this figure. We will see the details of each of these branches in the next few slides. First one is A key. This is a master key and we will discuss this A key in the next few slides in great detail. This is used for generation of the sub keys, that is the intermediate and session keys for use in authentication and encryption. Two intermediate keys are derived from this master key A. These are known as shared secret data SSDA and shared secret data SSDB, that is SSDA and SSDB. What is SSDA used for? This is used for authentication purposes of the mobile by the base station and the network. So what is the use of SSDB? This is used for generation of various session keys for scrambling all kinds of signals. Okay, fine. Now let's go down one level and look at what are the session keys. First key is voice privacy mask, also known as private long code mask. This is primarily used for encryption of speech. The second session key is data key. This is used for obviously encryption of data. The third one is CMEA, that is cellular message encryption algorithm key, CMEA key. This is primarily used for encrypting signaling messages. So there are three encryption keys. One is for speech, one is for data, and the other one is for signaling. Oops, there are so many of them. Okay, just don't worry. We'll make this as simple as possible as we go along. Okay, fine. In this slide, we will look at A key, which is a very important key for CDMA encryption in great detail. Look at the figures. There are two of them. One is the complete encryption mechanism for reference, and the other one is a small portion of that which deals with A key. Now what is A key? A key is a 64-bit secret key used to derive keys for three things: authentication, voice privacy, and message encryption. The security protocols with CDMA IS41 networks are among the best in the industry. For authentication, CDMA 2000 relies on three things: a 64-bit authentication key, an electronic serial number, and a random binary number called RAND SSD, which is generated from HLR or authentication center. This random number will be transmitted to the mobile each and every time when a call is made and will vary from call to call. No two subsequent calls will have the same random number. Please note this. The next one is about the A key. A key, as we said, is the most important key which determines the quality of the CDMA authentication, and we have also seen several ways in which A key can be programmed in the previous slide. Now this A key is programmed into the mobile and is also stored in the authentication center of the network. Please note, the A key for each mobile is unique and will not be duplicated in any other mobile. No one else will know about your mobile's A key except the network, that is the HLR and AUC. This A key is programmed into your mobile by the service provider when it registered with him at the time of subscription, or by any of the other methods that were discussed in the slide 1. Now these three parameters, ESN, A key, and RAND SSD, are mixed with another algorithm called CAVE algorithm. CDMA 2000 uses this CAVE algorithm. CAVE stands for cellular authentication and voice encryption, and the output is an 128-bit subkey called shared secret data. Look at the figure. ESN, A key, and the random SSD are mixed in a block using CAVE algorithm, and there are two resultant outputs, SSDA and SSDB. SSD stands for shared secret data. The total bit for the SSD is 128 and SSD B will have 64 bits and SSD A will have another 64 bits. Now let us summarize this A key. A key is programmed into the mobile. The A key also generates subkeys for voice privacy and message encryption. This is also stored in the authentication center of the network. The A key is reprogrammable, but both the mobile and the network authentication center must be simultaneously updated. Now there are different ways of programming the A key. It can be done at the factory, it can be done by the dealer at the point of sale, it can be done by the subscribers themselves over the telephone, and there is another thing called OTASP, over the air service provisioning, and this uses 512-bit Diffie-Hellman key agreement algorithm. We will not go into this algorithm in any detail, but it's always better to know what kind of an algorithm is used. Now why OTASP? For example, if your mobile has been cloned by your enemy, the A key in the mobile can be changed via OTASP, providing an easy way out to quickly cut off the service to the cloned mobile. Next one may be if you need new services to be provided to you by the service provider, your A key can be reprogrammed over the air using OTASP for legitimacy and also enhanced security. Okay. CDMA 2000 uses a standardized CAVE algorithm. We have already seen this. CAVE stands for Cellular Authentication and Voice Encryption, and security of the A key is the most important component of CDMA 2000. We will see more details about CAVE and the whole mechanism of encryption as we go along in this chapter. In this slide, let us look at SSD, Shared Secret Data. In the previous slide, we saw SSD is a 128-bit data output as a resultant of mixing ESN, A key and RAND SSD in CAVE algorithm. Now there are two parts to this SSD. SSD A consists of 64 bits. This is used for creating authentication signatures. This part deals with the authentication of the bona fides of a mobile subscriber. How is this SSD A generated? SSD is generated using the A key, the ESN of the mobile, and also the random number generated by MSC and sent to the mobile. These three parameters are mixed with an algorithm called CAVE algorithm to produce SSD A consisting of 64 bits and SSD B consisting of another 64 bits. During the authentication process, both the mobile and the network will compute SSD A and SSD B. Every time an authentication process happens, that is, a mobile is either originating a call or a SMS, or it is receiving a call or a SMS, this SSD A and SSD B will have to be generated. Of course, this whole process is initiated by the reception of a RAND SSD by the mobile from the MSC every time a call is made or received. Let us look at SSD B. This is also a 64-bit word, and this is used for generating keys to scramble voice and encrypt signaling and data messages. This part is involved in encryption of the conversation, that is voice and data. This ensures that no one else in the network will be able to eavesdrop and overhear the conversation. Please note, the A key and the SSD are never broadcast across the air interface. The A key is never transmitted over the air, and SSD also is never ever transmitted over the air.
Hi guys, hope you have enjoyed this video. Before you leave this, please ensure that you are subscribing to this. Also, please do like these videos and share it amongst your friends and colleagues. There are plenty of other videos, and I hope you will be able to find time to browse through all these things. Thank you.